Hello viewers, welcome to another session of our preparatory e-learning class. Now we're going to look at another set of examples which are quite tougher than this. Don't forget I told you that this is a tip of the iceberg. So let's look at the next examples. So these are the other examples. Part of these are jam-pass questions. Part of these questions are jam-pass questions. You will solve this and then I'll bring another set of examples which are YA past questions and we will still solve it. And they are very, very simple. So let us take them one after the other. Please, if you have not subscribed, subscribe to see more of our videos. If you are viewing this on a YouTube channel, on our platform, which is Preparatory e-learning. Don't forget that this dash, the hyphen, must be between preparatory and e-learning to take you straight to our YouTube channel. All right, to solve this, we have the first one. A is what? 5x into power 3 divided by 25x into power 6 all into power 1 over 2. This is still very simple. All you have to do, you have to first thing understand all the laws of indices that we have stated in our previous class. And if you understand all the laws, you apply it. This one you have power law is here, division law is here, you have power law also here, also have root power law as part of this. So you have a whole lot of laws playing out in this, but that is still very, very simple. How do we solve this? It is very simple. First thing first, you change this division, bring it under, you have 5x into power 3 divided by what? 25x power 6 into power 1 over 2. Hope you understand that. Division here is the same thing as this division here. Now, what do we do next? Don't forget I had said that when you have a power, this is under power law. When you have a power and you have some elements, some members in the bracket, this power distributes evenly on the elements you have in the bracket. Same thing here. This power distributes evenly on the elements that you have here. So how do we solve this? We now have that 5 power 3 times x power 3. Why did I bring in times? When you have a number and a letter joined together, to separate them is by multiplication. Multiplication sign separates two numbers that are jointly attached together. So this power 3 has distributed itself evenly on the members of this bracket. Same thing here. Divided by, we have 25. This power 1 over 2 will come on this 25 times x power 6. We also have this power 1 over 2. I had to put this bracket to separate because we have two powers there. We have two powers there. Now, what do we do there? What is 5 power 3? 5 power 3 is 5 times 5 times 5. Now we have 5 power 3. Let's just continue here. We have 5 times 5 times 5 times x power 3 all over this 1 over 2 as a power on 25 is like saying square root. You know, I had said that if you have x power 1 over 2 is what? Square root of x, for example. So here we have 25 power 1 over x. So this will have square root of 25, which is what? 5. So in place of this, we have 5 times. Now look at the next thing there is x power 6 into power 1 over 2. This is our power law. So what do we have there? We have x power 6 into power 1 over 2. This 6 and 1 over 2 will multiply out. 6 times 1 over 2. You have to cancel itself 1. To divide this, you have 3. 3 times 1, everything there is 3. So you have x power 3 here. X power 3. Hope you understand that. Now, moving further, we have this 5 here can divide one of these 5 on top. So this cancels this. We can see that. Also, we have x power 3 and x power 3 on top. This cancels that. So what is remaining there? We have 5 times 5 is what we have the remaining. We have the 5 times 5, which is what? 25. So the answer for this problem is 25. I hope you understand the simple steps that I have given, that we have used there. Okay, the next one is B, which says 16 power 3 over 4 times 4 into power 1 over 2 divided by 8 into power 5 over 3. The same thing we're going to do. In this case, we don't have more elements or more members coexisting, like when we have 5 and x, 25 and x. This one is just a single number, 16, 4 and 8. This one is cheaper, simpler. This is the coming together of our previous examples. Now, how do we do this? To solve this, we have 16 power 3 over 4. Don't forget, I have said, when you have a fraction as a power, the numerator represents the index, whereas the denominator represents the root. So we have fourth root of 16 power 2. So this is going to be fourth root of 16 into power 3. Fourth root of 16 into power 3 times, this is our root power law, which is what? Square root of 4. We have a square root of 4 all over. In this one, we have power 5 over 3, where 3 here as denominator is our what? Cube root, and then this 5 is our index. So we have cube root of 8 into power 5. Now, simplifying this, what do we have? Fourth root of 16 is 2. Power 3 times square root of 4 is 2, all over cube root of 8 is 2, and then power 5. This is like saying power 1, because anything to the power of 1 is that same thing. Now, how do we move on to solving that? Since we have all into same base, 2 here, and 2, we can easily combine our multiplication law and our division law, in as much as the bases are the same. If the bases were not the same, you don't combine all the laws together. You know, in JAM, speed is also needed, because I have a whole lot of questions to answer. So if you see a question that you can easily apply a shortcut to get to the answer, you just do that without wasting time and going over a series of steps. So quickly, to jump to our next step, there is what? We have 2 power 3. Because of times, we have plus 1. Because of division, we have minus 5. I hope you understand that. Minus 5 there. With the condition that the bases must be the same. You pick one of the bases, which is this 2. Now, 2, the first 2 has power 3, you write. Because of these times, you bring in plus. Now, this 1 comes on top of that. Because of this division, you bring in minus, and then this 5 is what you have there. Now, let us simplify that. That will give us what? That will give us, that is 2, 3 plus 1 is 4. 4 minus 5 is minus 1. 4, which is positive, minus 5. I had said, when we have different signs, you find the difference of these two numbers, which is what? 1. Now, which sign is with a bigger number? It is minus with 5, which is bigger than 4. So the minus sign, which is with a bigger number, will go with the answer. We have minus 1. So we have that 2 power minus 1. Or you want to bring in 1 over, which takes care of this power minus 1. You have 1 over 2. Therefore, our answer for this problem is 1 over 2. As we move on to another example. Another example, we have this Now, how do we solve this? The C part of this, we have 50x into power 3 over 2 equals to 32x into power minus 1 over 2. We have fractional power law or fractional index law. Here we have root law, negative root law. Okay, now how do we solve this? It's very simple. First thing to do, separate variables. Separate variables. Separate variables. Which we have separate variables. Separate variables. What are the variables there? We have this and this, x and x. We separate it. Now, how do we separate it? Look at it. We have, you bring x to x and 50 to 32. Now, we must know that there is no sign separating 50 and x. And there is no sign separating 32 and x. But there's one sign that is there, which is multiplication, not minus or plus. There is no minus or plus sign separating this, but there is a multiplication sign invisible separating this. So if we are to separate this, you divide through to bring this x power 1 over 2 to this side. You divide through by this, and to bring this 50 to this side, divide through by 50. Do we understand that? Let me take that again. To separate variables, you bring the letter that you have here, divide through by this. Therefore, this will come on this. For example, if I say divide through by x power 1 over 2, divide through by x power 1 over 2, you can see that this has cancelled this, leaving just this alone. Also, we divide through by 50. So this 50 will leave this place and come under this. I hope you understand that. So to apply that separate variable method or law, which is the simple approach in solving this, we have there, divide both sides by this x will come under here, and then this 50 will go under there. So we now have, this is going to look like this. We have x power 3 over 2 all over x power minus 1 over 2 equals to 32 all over 50. All over 50 there. 32 all over 50. Hope you understand that. If you are to cross multiply, you have the same thing. That means 50 times x power 3 over 2 gives 50x power 3 over 2. And 32 times this still gives you the same thing. If you cross multiply, you still have the same thing that we have here. Now, how do we do that? Let's proceed. Now, the next thing to do is what? You look at it. We apply division law here. And we also simplify this right-hand side. Now, to simplify this side, applying the division law, we have here, write 1x, because the bases are the same. The bases are the same. We write one base, we subtract the two powers. Look at it. The first power is what? 3 over 2. Because of division, we have minus and what? Power minus 1 over 2. Power minus 1 over 2. There goes again with same signs coexisting. When you have same signs coexisting, you have plus, because minus and minus, minus times minus is plus. You have it there for that one. Equals to, now something can divide this. Let's break this down a little. 2 can divide 32 and 50. 2 goes to 32, we have 16. 2 times 16 is 32. We have here 16. Now the same 2 can divide this 50. What do we have there? 25. You can see no one factor can divide 16 and 25. We hold on there. But let us simplify this 2. We have 3 over 2 plus 1 over 2. To find the LCM, of 3 over 2 plus 1 over 2. How do we do that? LCM of 2 and 2 is 2. You know, to find LCM of 2 and 2, what can go there? 2 goes here, 1 and 1. LCM is what? 2. You're right. 2 divided by 2 is 1. 1 times 3 is 3. Plus 2 divided by 2 is 1. 1 times 1 is 1. Therefore, we have 3 plus 1 is equals to what? 4 over 2. Now, this 2 cancels this 4. You have 2. So, in place of this 1 here, we have 2. So, bring it down there, you have this is equals to x power 2. A whole of this, which we have simplified this here, is 2. X power 2 equals to 16 over 25. Now, how do we solve this? We were asked to find x, but not to find x power 2. Now, what do we do so that, this 2 here can leave this x? Now, note, when you have power 2, anytime you have power 2, you take the square root of both sides. Anytime you have power 3, you take the cube root. Power 4 is fourth root. Power 5 is fifth root. Now that we have power 2, we take the square root of both sides. So what do we do there? You say take square root of both sides. Take square root of both sides. Take square root of both sides. If you are to move it up to where we have space, let's move it up here. Let's take that solution and complete it here. Let's move this. So up there. So you're going to have take square root of both sides. That means here you put square root, here you put square root. Just like saying x power 2. No, square root is what? 1 over 2. Power 1 over 2 equals to, same thing here. You can take square root here. You can either put it like this or power 1 over 2. You take square root there. What do we have? These 2 can cancel these 2. We have just x remaining there. You can put it like this, or you can still do it like this. You take normal square root, which is x power 2 into square root. Take square root of both sides. Take square root of both sides. So we put square root here, we put square root here. Now this square root cancels this square. What is left is just this x equals to what? We have square root of 16 is what? We have 4. You know, 4 times 4 is 16. We have 4 there. All over square root of 25 is 5. Therefore, x is equal to what? 4 all over 5. That's the solution for example C, which is what? 4 all over 5. Then we will move to solution D. The question we have, this is still very simple. Let's remind ourselves of this law. We had as one of the laws of indices the zero power law or zero index law. Be it a number or a letter raised to the power of 0 is 1. So here we have, to solve this, we have 2 times 1. In place of this y power 0, we have just 1. And 2 times 1 is 1. Let us move on to another one. Times power minus 3 distributes itself on every element we have here. The first one is what? We have 3 power minus 3 times, the next one is what? Y power 2. I have to put this in bracket to separate, minus 3 times 7 power 0 is 1. Now here we have 2 times 1 is equal to 2 times 3 power minus 3. Don't forget that power minus means 1 over 3 power 3. 3 power 3 times, now we have 2 times minus 3, we have minus 6. We have y power minus 6. So solving that further, we have 2 times 1 over, what is 3 power 3? 3 times 3 times 3, which is what? 27 times, now 1 over, will take the place of this power minus 1 over y power 6. This will give us what? 2 times 1 is equals to 2 all over 27 times y power 6. Just take this, join with this. 27 times y, we have 27y power 6. Since this cannot divide this, that is our answer. Now, the next one is our E. Let me leave this for you to solve. Solve it on your own. It is simple. Just try it alone. You will have it. I'll solve just this one. I'll solve the last one here, which is F. F is 0.25 power x equals to what? 16. This is an example of our exponential equation or exponential function. So how do we solve this? We have a decimal number here. Anytime you have a decimal number in an indices, you change from decimal to fraction. We change from decimal to fraction. Now, how do we change decimal to fraction? Note. First thing first, let's look at 0.25. How many decimal places does this decimal number have? We have, from the points here to the right, we have decimal number or decimal place. So we have 1 and 2. This fraction has 2 decimal places. Because of that, we divide this number, you ignore this, the decimal point, we divide it by 100. Why 100? Because 100 has 2 zeros. The number of 0 must correspond with the number of decimal place. If it was 1 decimal place, divide by 10. Because 10 has 1 0. The number of zeros must be the same as the number of decimal place. So we divide these decimal numbers, removing decimal point, by 100. Because 100 has 2 zeros. So to proceed there, we have, ignore the decimal points, you have 0 to 5 over 100. 0 before a number is irrelevant. So what do we have there? We have 25 over 100. So in place of this 0.25, 0.25, not 0.25, 0.25 is what we have here, 25 over 100 into power x equals to what? 16. Equals to 16. So, and of course, you know that if the decimal place was up to 3, you divide by 1,000 because 1,000 has 3 zeros. So how do we do this? We can find that 25 can divide 100. What do we have? 1 over 4. 25 goes here is 1. 25 goes here is 4. 25 times 4 is 100. 25 times 1 is 25. So this cancel this, you have here 4. So you have 1 over 4. Here you have 1 over 4 into power x equals to what? 16. We know that 1 over, you have 4 power minus 1 into power x. Hope you understand that. I had said that 1 over means power minus 1. You have 4 power minus 1 into power this x equals to, let's reduce this 16 into base 4. If you are using 4 to divide 16, how many 4 do we have in 16? 4 goes to 16, 4 times, 4 goes to 1, we have 2 4. That is 4 power 2. We have 2 4. 16 is what? 4 power 2. 4 power 2 is what? 4 times 4, which is 16. So in place of this 16, we put 4 power 2. The whole essence of exponential function is to make the base to be the same. So try to simplify and reduce either the base to be the same or the index to be the same. So let us proceed. Let's finish up this one. Minus 1 times x, you have 4 power minus x equals to what? 4 power 2. Now when you have same base, equate the index. For same base in an exponential function, what do? Equate the index. For same base, you can see that the bases are the same. For same base, equate the index. Equate the index or the indices. Equate the index that you have there. So, what do we see? You can see that this one can go with this. We equate the index, which you have. The first index is minus x equals to the other index is 2. If we have to find x but not minus x. So what do? This is like saying minus 1. There, minus 1x. To take out this minus, divide by minus 1, divide by minus 1. This cancel this, you have x is equals to positive divided by negative is negative 2. So the answer is x is equals to what? Minus 2. These are the simple solutions to all of these questions that we have solved. And let us go to the third batch of these calculations of indices question, and these ones are likely WAEC questions. If you are a JAMBite preparing for JAM exams, if you can solve these WAEC questions, that means there is no question in JAM under this topic called indices that you have a challenge solving. So the next phase we're going to go now is WAEC past questions on these indices.